Well, before our fire alarm, this is where we were at. I forgot to record, don't worry. So, not planned at all. So, I'm just starting the recording. I forgot to before. Take a look at the review of the first derivative test. You know all about that. Concavity, if it's concave up, the second derivative is negative. Stop and look at that. We can summarize with a sad face to remember second derivative negative. I said concave up, I'm mistaken. Concave down, second derivative is negative. If it's concave up, second derivative is positive. Take a look at that. I'm just recording now, I've forgotten before. We looked at some sections. Concave up, concave down section, etc. We were just talking about the consequences of some of these things. The second derivative test, once again, can be summarized with happy and sad faces for the second derivative test. I will do one example. That will be it for now. So, yeah, that'll be about right. So, find the maximum, minimum, concavity, and inflection point for the following function. Oh, there's a minus 3 on it. 2 sine x subtract 3 on 0 to 2 pi. Now, I think you can hopefully picture this even in your head. If you can, because I like to start with functions where we kind of know the answer. 2 sine x, right? So that'd be like up and down 2 between 0 and 2 pi. But then the subtract 3, what does that do to this graph? Like normally you'd have this as a height of 2, that's negative 2, right? Moves it down 3, so that goes from negative 1 down to negative 5. Yeah. And its center line is actually at negative 3, right? Moves the center line down 3. Think it that way. So there's definitely going to be increased, like on this we should see increase, decrease, increase. We should see concave down, followed by concave up. Probably changes at a value of pi. How are we going to show that? Well, let's do some derivatives, I guess. F prime of x. In this case, the 2 sine of x minus 3, well, the 3 disappears. 2 cosine of x, good. And the second derivative, the derivative of the derivative of 2 cos of x, negative. So, as long as you remember the negative sign of sine of x. Then what? Well, I'm going to kind of skim over this 301 at being, max, min, concavity, and inflection points. Now, maxes and mins we've seen before and stuff like that, so I won't focus as much on concavity and inflection points, though, are the new things, right? So we'll make sure we see that. But let's just see here. This is pretty simple, I hope. Anyways, the red here, this finds the max and min. I'm just not going to make big statements here. F prime of x equals 0. So why am I writing that? So 0 equals cosine of x when x equals, remember we're only going from 0 to 2 pi. You can think about this, right? If I was talking about 2 cos of x, it looks like this from 0 to 2 pi, right? Didn't draw my x very carefully. It doesn't match the scale of the one underneath. So, where do I get my zeros? In radius.
0, pi.
I get my zeros at, 2 pi for cosine, right? Cut this in half. What do you call this value here? And what do you call this value here? Pi halves and? Pi halves, yeah. And if you're not familiar with thinking in radians, you know that this is 1 pi here, right? If you draw this correctly, this is halfway to there. 1 half, 2 halves, 3 halves, right? So x equals pi halves, or x equals 3 pi halves. So those are our critical numbers. And you already know where the maxes and mins are, right? Now, if I drew this better here, you can sort of see it match up, right? Okay, that's still pretty crappy there, but anyways, I'm just having a hard time drawing today. Anyways, yeah, something like that. My min doesn't match up very well anyways, but you get the idea. It's obviously a max at pi halves, a min at 3 pi halves, right? We won't go into that though, because we've explored that a little bit. What I want to make sure we focus on was the inflection point idea. So the second derivative, I'm changing the blue for that. Possible inflection point when the second derivative equals 0. Yep. I'm sorry, what's that?
Isn't that just a sine graph that you choose to pick, not negative sign?
This sine? It is basically what I was drawing here. What I'm drawing here in green is the original function.
I thought you trying to.
Oh, no. I'm because that's where the reason why I was saying it makes sense. This is a max. This is a min. I'm not going to go into it and write the detailed things, but we have enough information we can do this, right? Max. It's just with the bell. It's the fire alarm. Okay. Now, with this green, the original function, you know that we're probably going to get pi as our inflection point. And you think, though, if you didn't know this function, though, you set it equal to 0, and you say, well, in between 0 and 2 pi, you know this round bracket, eh? Not included, 0 or 2 pi. The only 0 you get is at pi for sine. So I'm going to write that down. X equals pi is the possible inflection point. Now, I'll just wait. That's the possible x value for the inflection point. Now it's a point, so you have to find the y value that matches with it. But just a second here. Inflection point. The sign of the second derivative changes at a point of inflection. So with this particular one, we shouldn't find it too challenging, I hope. I'm going to do what we've been doing before, some sign analysis here. -2. We can just consider this as one chunk here. At pi, and we know that we're starting at 0, ending at 2 pi. This is our 0, -2 sine of x. If you put, we'll do the easiest sine value you know, probably pi halves, in between 0 and pi, right? What is the sine of pi? I'm not worried about positive or negative in front of it yet, the 2. What's the sine of pi? Halves, I mean? 1. 90 degrees, but I don't like talking in degrees, right? Getting used to. So that's the 1, but then you multiply by -2. Okay, so this whole region is negative. This whole region is positive. If you test it out with 3 pi halves. How could I have done that if you didn't know squat about this, but you knew this sine function is not -2 sine? You'd say, well, yeah, pi halves, it's +1. It's a positive. That's all I really need to know. There. So I put a positive into this and multiply by -2. I get the results I have. Now, it switches signs from negative to positive. It's definitely an inflection point. And I guess to be a point, we had to plug pi into the original function 2 sine x minus 3. So f of pi 2 sine of pi, subtract 3 from that answer. Tell me. Sine of pi, 0, subtract 3. So negative 3.
Just using our sign analysis little thing, we say it's concavity.
Not even, well, okay, the concavity we can do after, but just that it's an inflection point
Yeah.
first to make sure it switches signs, and also then the concavity too. Because confirm that the sign of the second derivative changes. That's a point of inflection. So I guess, so x, so pi comma negative 3 is an inflection point. Since the sign of f prime, double prime of x switches signs. It doesn't matter if it's negative to positive, positive to negative, by the way. This isn't like maxes and mins where the order. You just have to be sure that it switches signs. I'm going to put from negative to positive, but that's not necessary. And it is concave down, and I'm not going to go any further on this because the bell rings in 1 minute. Concave down from 0 to pi because the second derivative is less than 0. Concave up from pi to 2 pi because the second derivative is positive. It's greater than 0. Okay? Now, unfortunately,